Hi everyone, welcome to IGCSE Chemistry with Abu Qai, the Chem Dude. Today we'll be looking at electrolysis of aqueous copper 2 sulfate using copper electrodes. The first thing to be considered in this electrolysis process are the ions present in this electrolysis. Now, the ions that are present will come from two sources. One, our ionic compound, and that is the copper 2 sulfate. And secondly, the fact that it's an aqueous solution, it means that water is present. So we must consider the ions that will come from water, H2O. So those are the two sources of our ions. Our copper 2 sulfate, that is CuSO4, and H2O. Now the ions that will come from copper sulfate are the copper ions, Cu2 plus ions, and SO4 2 minus ions. So these are the two ions that will come from your copper sulfate. From water, when water partially dissociates, it produces H plus and OH minus ions. So the ions to be considered from water is H plus ions and OH minus ions. So as you can see there, you've got two positively charged ions and two negatively charged ions. Two positively charged ions and two negatively charged ions. Now the positively charged ions are attracted to the negative electrode. That is this electrode there, and that electrode is called the cathode. So the positively charged ions are attracted to the cathode. The negatively charged ions, that is your sulfate ion and your hydroxide ion, are attracted to the anode, the positive electrode. The positive electrode is called your anode. Okay, now you've got two negatively charged ions and two positively charged ions. The two negatively charged, let's start with these ones first. The two negatively charged ions, they are called anions. A-N-I-O-N, anions. Why? Because they're attracted to the anode, so they're called anions. So what's your guess for the ions that are attracted, the name of the ions attracted to the cathode? Take a minute and think of it. What do you think the ions attracted to the cathode are called? Okay, these ions are called cations, C-A-T-I-O-N, cations, because they're attracted to the cathode. Okay, so since we've worked out the ions present in our electrolyte, now we need to work out which ion will actually form the product at each of the electrodes. Let's start with the positive electrode, the anode, and the anions. So we're looking at the sulfate ion and the hydroxide ion. To know which ion will form the product at the electrode, okay, we need to look at the rules. The rules that governs what the product at the anode will be, which ion will move to the anode to form the product. Both of them cannot form the product at the anode, only one of them. Both of them are attracted to the anode, but only one of them will form the product at the anode. Okay, so to know which one of them will form the product at the anode, we need to look at the rule. And the rule states that if the solution is concentrated and it consists of a halide ion, then the product at the anode will be the halide ion. For any other scenario, the product will be oxygen. For any other scenario, the product will be oxygen. So again, I'll repeat the rule again. If your electrolyte solution is a concentrated solution of a halogen, and it has a halogen ion, and it has a halogen ion present. The halogen ions are called halide ions. Okay, and those are elements from group 17. They form halide ions. So we're talking there about chlorine, okay, bromine, iodine, fluorine, these are halides. Okay, so they form halide ions. They are halogens and they form halide ions, ions with a negative charge. So if your electrolyte solution is concentrated and one of these ions are present in that solution, then the product at your anode will be the halide ion. Okay, so if chlorine is present, the product will be chlorine. If it's bromine present, then the product will be bromine. If it's iodine or fluorine present, okay, in their ionic form as ions, then the product will be the halogen ion. Okay, provided that the solution is a concentrated solution. For any other scenario, the product at the anode will be oxygen. So for example, let's look at some other scenarios just to cover all the bases. If you've got a diluted solution of a halide ion, what would be the product at the anode? Take a minute and think about that. When you're ready, continue the video. Okay, if you've got a diluted solution and it consists of a halide ion, the product at the anode will be oxygen because the conditions are clear. You must have a concentrated solution, not diluted, must be concentrated, and the halide must be present. Okay, for any other scenario, then the product at the anode will be oxygen. So if you've got a concentrated solution but no halide, then what would be the product at your anode? It will be oxygen. Now, how will oxygen form at your anode? The hydroxide ion there, your hydroxide ion there, will move to the anode and it will give up its electron. It will give up its electron to the anode. That electron will travel through the circuit from the anode to the cathode. Follow the arrows. The electron will travel through the circuit from the anode to the cathode. Okay? Now, we will come back later on to talk about what happened to these electrons once they're at the cathode. But let's continue about what happens next with this hydroxide ion once it has given up its electron. Now, what I'm going to write here on the side is the half equation for the reaction at the anode. So half equation for reaction at anode. So the half equation for the reaction at the anode is as follows. 4OH minus, each of them will lose one electron. So in total, 4 electrons would be lost because you've got 4 of them. Okay, so minus 4 electrons goes to form 2H2O plus O2 plus O2. So that's the oxygen there that will form the product at your anode. So at the surface of your anode, you will see bubbles of oxygen gas being formed there. And those oxygen gas will rise to the surface and escape into the atmosphere. You can test to see, to make sure that this is oxygen, okay? To determine that this is oxygen gas. And you can test by dipping a glowing splint into the test tube that contains the oxygen gas, okay? And that glowing splint should relight. The glowing splint should relight, and that would be proof that the gas that is emerging there from your anode is actually oxygen. So that's the test for oxygen, and this is the half equation at the anode. Now notice that this half equation is showing that electrons are being lost, minus 4 electrons. So minus there meaning that it's being lost. And whenever electrons are being lost, then what you're experiencing there in terms of redox reaction is oxidation, OXI. So what you're experiencing there is oxidation taking place. And this is always the case. At the anode, oxidation always takes place. Okay? Whenever a ion moves to the anode and give up its electrons, okay, it loses its electrons to the anode. Oxidation always takes place at the anode because oxidation is defined as the loss of electrons. So our hydroxide ion there lost its electrons. So it is oxidation. And you can always tell because here you'll have -4 electrons. Okay, now what happened to those electrons? We said that they travel through the circuit, okay, from the anode to the cathode. Now at the cathode, you've got two cations being attracted to this negatively charged electrode, our cathode. Now only one of them will form the product at our cathode. But what determines which one of them will form the product at our cathode? The thing that determines which one will form the product at the cathode is what we call the reactivity series of metals. And the rule for the product at the cathode states that the more reactive of the two ions will stay in the solution as an ion, and the less reactive will move to the cathode and form the product. So all that is left is for us to determine which of these two cations is more reactive. Okay, because the more reactive one will stay, and the less reactive will move to the cathode and give up its electron. To know that, we must look at the reactivity series of metals, which are as follows, which is as follows: potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, lead, hydrogen. After hydrogen, we've got copper, then silver, then gold. So these are the symbols that represents the metals, some of the metals in the periodic table. Okay, reactivity increases as we go from bottom to the top. So the most reactive is potassium, least reactive is gold. Okay, now according to the rule for the product at the cathode, the most reactive of the metals will stay in the solution, the most reactive element, okay, because we've got two elements here that are not metals, carbon and hydrogen. So I say the most reactive ion will stay in the solution. The least reactive will form the product at the cathode. So the least reactive, as we can see here between hydrogen and copper, is our copper, because hydrogen is above it. Hydrogen is there, copper is there. So hydrogen is more reactive than copper, so hydrogen will stay as an ion, and copper will move to the cathode, where it will accept the electrons that were given up by the hydroxide ion. So every copper ion there will accept 2 electrons to become a copper atom. And that copper atom can be seen coating the surface of our carbon cathode here. Okay, so the cathode, the surface of the cathode should be a copper color. Okay, so if I was to use this as a copper color, our cathode, the surface of our cathode, starting from the edges, should start to look kind of yellowish brown, the color of copper, until all of it would be um, coated with the copper metal. Okay, so this is what you will see. You will physically see this at your cathode. Okay, that metal there is copper metal that is being formed at your cathode. Now we'll quickly look at the half equation for the reaction at the cathode. So at the cathode, you have your Cu2 plus ions we're talking about these ions here, Cu2 plus. They will move to the cathode because they're the least reactive. Okay, hydrogen wouldn't, because hydrogen is more reactive, so it will stay. More reactive, stay. Yes, least reactive will form the product. So our least reactive ion there is our copper ion. So it will move to the cathode. It will accept 2 electrons, 2 negatively charged electrons. That will neutralize these 2 plus charge there. So 2 minus will neutralize the 2 plus there. So you will have a copper atom being formed with 0 charged. Atoms, as you know, has got 0 charge. Of course, atoms will be bonded together by metallic bonds to form the metal copper at your cathode. Now note here that this half equation shows that electrons has been gained. Electrons has been gained. So whenever electrons are gained, this represents reduction. So we say this is a reduction half equation at the cathode, because this is occurring at our cathode. So it's a reduction half equation at our cathode. Here above, this is an oxidation half equation at the anode. Okay, so oxidation at the anode, reduction at the cathode. How do we know this? Well, at the anode, electrons are lost, minus 4 electrons. At the cathode, electrons are gained, okay, plus 2 electrons. Okay, so this is all for the electrolysis of aqueous copper 2 sulfate using copper electrode. Until we meet again, thank you very much. See you soon.